Hey guys, so I am trying to figure out like a quick way to explain this one for you. This one is not a difficult problem, it just is a lot of like really small steps. So let me see if I can go through this and you can follow along the book. It's page 278. It's at the top called Sample Exercise 17.4, Preparing a Buffer. So how many moles of NH4Cl must be added to 2 liters of 0.1 moles of NH3? To form a buffer whose pH is 9. Okay, there's a lot of information there. So let's simplify this. First of all, anytime we're talking about NH4Cl, what we're talking about is NH4 with a plus. So how do we get the NH4 with a plus? So if I take my NH3 plus water, what happens in an equilibrium is that I produce then NH4 with a plus. Okay, so this is now like my working equation. Okay, this is the actual chemical equation. My working equation would look something like this. Now, there should be somewhere we can find the Kb of NH3. If you look in the back of the book, you will see that it says 1.8 times 10 to the negative fifth. That's the Kb for NH3. And that also equals, then of course, if we're looking at this, that also equals you can check this out in the book also, NH4, by the way, I left that out of there. That should be NH4 OH minus. My board's doing a wavy thing. So NH4 with a plus and OH minus. This is not my handwriting. This thing is just going nuts. Okay, and that is not what I'm looking for. There we go. That's better. And this would be the NH3 right here, like that. Okay, so this is what we're looking at here. Notice that we have our base here with the OH. I have my NH4 plus here. So if this is a buffer, that means I have my base here, my weak base, and conjugate acid right here. Now, here's the key. The key is that we're going to be solving for this one once we get to that point. So the first thing we do is we look at the pH of 4, pH of 9, and we try and figure some stuff out. I can do this one of two ways. I can take 14 minus 9, okay, to get 5, and that equals the pOH. Okay, if you guys remember the stuff we talked about with pH, pH equals the negative log of the hydrogen ion. The pOH equals the negative log of the hydroxide ion. Okay, so once we find this one here, and we know what this one is because in the problem it says 0.1 molar, okay, and then we can find out what that is. So let's find the OH first. I find this is 5.0, which means I need more room here. What's the opposite of this? 10 to the negative pOH, which equals 10 to the negative fifth, which means that when I plug all of this in here, 1.8 times 10 to the negative fifth equals NH4 plus the concentration, which is what we're looking for. Now this one is the OH. That's times 10 to the negative fifth. That's what that is right there. And this one is 0.1 because that's what it says up top in the actual problem. So the only thing we're doing now is solving. So I multiply both sides by 0.1 and I divide both sides by 0.0001 like that. So that means this here gets multiplied by 0.1 here and divided by by that. A little bit more room. NH4 positive, the concentration after this equals 0.18 molar. If you do this calculation right here, equals that. And then concentration times equals number of moles divided by volume. And if we're solving for moles, that equals concentration times volume. So our volume is 2.0 liters like this. So that means 0.36 moles NH4Cl. Okay, so I'm going to call this part 1. I'm going to stop here. Now you can see how to do a long, easy problem of finding how to prepare a buffer.